First of all, it's my honor to be here among these amazing speakers. And thank you, Kristen and Noor, for inviting me for this conference. I'm Deena El-Mahdy. I'm assistant professor at the British University Egypt, Architecture Engineering Department. And my topic today will be mainly oriented toward digitalization on society, focusing on the 3D printing in architecture. A brief who am I? I get my bachelor in 2010 from Cairo University, Architecture Engineering Department, followed by my master's in 2013, where then I started to orient my interest and research towards the digital fabrication and virtual reality. After then, through my journey to my PhD, I have been integrated into different workshops and competitions related to 3D printing, entrepreneurship, augmented reality, and so on. Through my journey after this, I have been in my PhD generated a 3D salt printing blocks, which I will mention them later. I have been also get some recognitions in digital fabrication and entrepreneurship related to 3D printing and additive manufacturing. I always like to start with this slide because these social workers have a lot of lessons that they can teach us. And actually, these small, tiny insects are the best 3D printers, as we will see through the talk. So before I start, I would just need to highlight something about the architecture, which is considered one of the most humble professions in the world, because we even start to provide the social aspect and good life health to the people. But there's a very serious problem that we need to consider and to ask ourselves that do we really respect our environment? Do we really respect our local materials and something like this? And if so, who are smarter, the insects or us? So when we focus about these tiny insects, we can find that these insects can have a very high-tech machine inside their storage containers. So, and even there are very smart techniques that they consider during their homes or constructing their colonies itself. For example, the bees can even compute the maximum or the best performance of the foam generation that allow them to generate a beehive form in a sort of hexagon form, which can allow them to restore the maximum amount of honey with the less amount of material. So the material that they are making the hive with is wax. So how they are sustaining the material and only print the material that they only need. Also the termite mound, which even the ants or the termites can even orient their colonies or the mounds toward the wind direction. And even in the side of the air or the wind direction, they make like a sort of pores to allow the air to be inserted inside the colony and even cool the colony itself. And even we have in architecture, Mike Pierce, where he mimicked the same process of the termite mound, and in the Eastgate Center in Zimbabwe, where he didn't use any sort of air condition, just a fan to pull the air outside the building. One of the main interesting also thing that ant can generate is that they can recognize the shortest way from their nest to the food and back through even generating like some sort of pheromone on the way itself, and even the shortest way where the ants can move on many times will be the shortest thing. So they are doing like an optimization process, and we will see later on how this optimization can be implemented in the 3D printing. This is Shibam city in Yemen, where they are using the same process of the wasp colonies, and both of them are using the clay during their construction. This is another traditional construction techniques that is used in Egypt, where they are using like small clay pots and the construction and plastering with the clay. And this is also similar to the beehives colonies. Even if the same wasp or the same insect, which is the wasp, it can have a lot of different materials, and each material depending on the context that in. So if there is a wasp inside or in an environment related to desert, they're gonna use the sand, and if it's in a place that is full of forest, they would use the woods and the trees. And even if they are using the same material, if they have found a colored material, they're going to use the same material from their feet. So there is quote by Hassan Fathi, one of the greatest architects, said that you should build what beneath your feet. So we need to respect really our local materials and build with it. This also tiny crab can 3D print their sand oculo in a very fast and simple way using only sand and water. And as you see here, he just started building in a very spiral way, and these are a very stable oculos. This takes us to the biomimicry approach, which we even need to mimic our ecosystem. We need to mimic the behavior of the insects and even how they perform and sustaining their materials. Who are familiar with architecture, there is a sentence that called form follow material. This form follow function, and I think due to a lot of different techniques and optimization software, the form became now follow materials. And even the material itself have a lot of optimization process, which can allow us to generate a very complex form in a very sustainable way. By highlighting one of the insects, and let's see how high the structure of the ants can be. This is a small comparison between our size and the ant size, and we will make a small estimation for each one of us how high the buildings are or the construction we can reach. So here we are 700 times the ants, and even the ant itself can reach building their mounds up to 12-meter high, which is around 4 floors. And this is actually 6,000 times their scale. When we compare this with the construction that we build, the maximum height that we reached till now, which Burj Khalifa, it's around 800, around 400 of our scale. And when we put these numbers together, we can see how tiny the ants reached, also around 6,000 their sizes, but even the human only reached 400 their size. And even this is also with using only earth. So the materials, the insects are similar to the process itself, similar to the 3D printing, where they are using a layer by layer in order to generate the same performance with a very less material and sustainable way. This is a very traditional construction made out of mud and built in Cameroon, and they are using this type of earth in doing this type of structure. Mangus Larison has injected a different type of bacteria in order to solidify this sand and reach this solidified buildings. Thomas Liberty also have generated this mold in order to allow the bees to generate or 3D print their hives inside this mold. This is also a pavilion done by MIT Media Lab, a silk pavilion where they are using the silkworm in order to time their structure and 3D print their structure on this skeleton. Another example also where they mimic the process of the spider under the water and allow the robotic arm to generate the same method to generate this pavilion. So there's a problem in using our tools, and even we need to check if it really will allow the people to lose their jobs, or we are need to get more developed or develop our skills. Before centuries, we have noticed that we started to live in caves, and through centuries we have been inserting different type of tools like manual tools, mold. We have been burning the bricks and precast. We integrated some sort of insects to help us in the design, and after then the 3D printers, the robotics, and different type of drones that help us in construction. So here, by the development, we can realize that the tools are something that is changing and the material are constant. So either you are in Mars or the caves or whatever planet, you can use only the material that beneath your feet. So this challenge and competition was launched by NASA, where they launched the 3D printed habitat for Moon and Mars. And this allowed the designers to get some inspiration, ideas, and how to use the material on the site itself through using the robots. So they are training now the robots in order to send them to print directly on the site. So innovation is there, but we need to ask ourselves how to add value to something that we really, or it's about creating something that is based on our needs and requirements. I've noticed that people in the small have adapted to face this pandemic and even get used to online classes and digital screens. So skills can be even taught and developed the people, whatever their ability. This chart are done by Ronald Berger's study, where they are comparing between the robotic and the operator cost. And as we can see here that the robotic started to in a very high cost and started to decrease gradually. However, the operators costs are still increasing in a very high way. Unfortunately, this chart cannot be applied 100% in our Middle East and Egypt, because we have a lot of very cheap labors. So it's a type of hybrid system where the machine can assist the human, not replacing them. Most of us are familiar with Charlie Chaplin feeding machine, where the factory needed to manufacture a machine that can save the lunch time of the workers in order to save much time to be working instead. So there are a lot of benefits through the innovation in the technology and the machine, but in some places they can be a silent killer for many jobs. So additive manufacturing and robotics industry have been most popular in very different fields like astronomy industry, medicine, nanotechnology, but in construction and architecture, it's increasing at a very slow rate. Although there are a lot of benefits, such as it can reduce environmental pollution, we can even generate a mass customization, cheap material, and in a very complex and fast way with less material. But there are similar some problems or obstacles that we are facing, such as the on-site application and even in the large-scale process. The printing evolution started from the 2D printing, and even most of us have been tried the 3D pen, and even started to now develop to reach the 3D printing, and how they even assess the robots now assisting in the 3D printing. The evolution started also of the material, how to be sustainable material, and even the future of these materials. In architecture, we can even build with sand, clay, concrete, plastic, mycelium, algae, and salt. And even there are a lot of materials now are being invested. So this put us why tomorrow's architecture will use yesterday materials. So we are now using the old materials, we are reviving them and using the new tools instead. So the technology is there, but what we are solving, this is a very hard question that we need to ask ourselves. These are two images for the same material. One of them are using a very conventional and traditional technique where they are generating a very bulky and heavily mass material, comparing to the other one, which is a 3D printed ice cream and even can generate a very appealing form with a very lightweight and less material. So this is simply how the 3D printing work in architecture. So these are some exploration from different factories and how they are even applying 3D printing on site directly. Also, there are applications like generating a direct wall, or even you can generate a small blocks and assembling them on the site directly. Also, there are a different type of concrete printing where they are trying to invest in something like weaving or giving reinforcement according to the form itself. So the form can even replace the reinforcement itself. This is similar to the morphology of the bones, and where we are only putting the materials in the spaces that we need. So optimization is very important, and even there are a lot of softwares that can allow us to generate this form that is optimized, where we can even get a lightweight material with a small thickness and less material, and which will allow us to generate a less also cost. This is also an experimentation where Marcus Kaiser tried to centering the sand in the desert. Here Ronald Ruttle started also to print by salt. Another application by IAC where they are tried to use the clay bricks, and here are different type of bricks where they are using thermal masses or thermal gaps in order to generate the thermal gaps, and here some bridges application also. So when it comes to building house in 24 hours, we need to ask ourselves, is it about the speed? Is it about the quantity or the quality? Hassan Fathi is the greatest architect, has mentioned that God has created in every environment the material that can cause its problem. And the brilliance of the architect and how he can deal with these materials and the environment. So we have a lot of traditional construction techniques in Egypt that even aware of the sustainable materials. However, we are replacing in the new capital city that we are constructing them with different industrial materials. Here are some vernacular architecture from Egypt that, as you can see in each image, the buildings even are fitting in the climate or the context itself. This image, what allowed me to focus more on the 3D printing, it's a new Gona by Hassan Fathi, where he started in Luxor, where he started to make the village with using mud bricks. And now the concrete monster started to appear in this country. So I have been applied and integrated in different workshops related to material, where I started to use a different 3D printing process in order to generate or to be aware of the sustainable material. Here our 3D printed sand table, where we just printing the form of this table, and even there was no waste of the material. In this project, we used a filament made of algae through using the 3D printing. So it's really a different materials that I try to apply to get use of this sustainable material. So here is the last project I'm showing, which is related to salt architecture. And even most of the people, when they hear salt, they are making some fun. Like, if I need some salt, I'm going to put my food from the wall itself. So actually, salt architecture, it's a traditional construction technique that was used in Siwa oasis. It's in the western desert of Egypt. There is a traditional technique called karshif. Karshif is a combination of salt block and clay. So in this oasis, they are trying now to transform this construction into concrete and limestones and fire bricks. So I started to say that, what if I'm trying to integrate the 3D printing in order to following the same material they are using and reaching a different forms. So it's a type of recalling the vernacular architecture. And this is Adrial Amiral Ecolodge. You can check it later. And this is one of the most used ecolodge that doesn't use any electricity. This is mainly the process and how they can even put like the same process of the wasp built block by block and by just plastering from the side. So there was no material, or there was no tools, 3D printing available tools, and even the fab labs in Egypt refused to put my materials inside their machine. It was sand and salt and a binder that need heating under 150 Celsius. So I started after then to generate or manufacture my prototype of the 3D printing that can be suitable to the material. And I generated some blocks out of sand and salt, and as you can see here, and even it's still under experimentation to make like a mass production from, and can generate a building or a wall. So at the end, 3D printing can even provide a cost up to 30 to 55% compared to the traditional construction technique, which is can be very fast. We can generate a very complex form in a good quality, and even with less material, no scaffolding or no formwork. Some challenges will be related to the on-site, the upscaling, and even the cost. At the end, we need really to learn from these social workers how they are sustaining their materials, the process, and the construction. And thank you.
Thank you, Deena. That was absolutely fascinating. I love the tie of the insects. I think that is so, I feel like I learned so much from that. There is some questions. First question is, did you build this 3D printer all by yourself without any help?
Okay. Actually, as there's a very multidisciplinary approach in this track, so I in the electrical issue, I get help from electrical engineering in order to make the electrical work and so on. Other than this, I have been producing all the things, other things by myself.
So cool.
Yes.
I think you kind of addressed this, but there was a question on what do you think is the number one reason 3D printing and architecture is being adopted so much slower than other industries?
Actually, we have a very serious problem in the manufacturing or even putting a large scale construction. So up to making a small prototypes, it will be very good in the time even, and to be mass customized. But there's a problem, and I think till now it's in the mass production because most of the people are needed to, and even the real estate need to make like a very fast way in construction, and they don't have the time to test the clay material and other things. So, and even you need to change even the culture of the people themselves. So we cannot put or print the machines or put the machines itself in very remote areas and tell the people that you follow this process. But even we need to respect how they are building with, and even if we are providing them a help, or even the machine can help, then we can go for this. But there's something really, to be honest, that and the developing country itself, most of them have a lot of different traditional techniques. And even when it comes to building with concrete, most of them are now saying that, yeah, because I'm in an old fashioned way, I will use the concrete, which is very modern, like the ones in the city. So they even try to turn their traditional techniques to concrete, which even can get them a very vertical height. So I think this is one of the main problems of the 3D printing in architecture, that we cannot now reach up to 3 stories height, I think. So this is one
So
of
we
the
only
main
have 2 minutes,
issues.
but I wanted to ask you one last question, just hopefully you can answer relatively quickly. I really love the tie-in with the insects, and I think it's a really good point that we can learn a lot from them in terms of building. Are you actually involved in research on this topic, or are you using it more as inspiration?
Actually, I have been since 2013 doing a lot of research related to insects, and even because I love photography, and I tracking how the wasps are building their homes, how the bees, how the ants, and so on. So I try to really find a link between these insects and the constructions, and even the process of the 3D printing. So this track I tried as possible to integrate in my fields, and even my fields are academic, and part of it is need an application. So we are trying to invest in the concrete and clay printing in a current project, and hopefully I can really generate or even prove this statement that the ants can
Well, I think that
even
one
learn
slide where
and
you
teach
showed
us a
that,
lot.
they've been able to master a scale that is well beyond what humans have been able to do. There's got to be something we can learn from that. It's pretty cool. Thanks, Deena. That was just really, really fascinating
Yeah,
presentation.
yeah,
So thank you. I really appreciate it. And thanks for it's quite late
you're
there, I
welcome.
think. So appreciate that as well. All right.
Yeah,
Thanks, Dan.
thank you.